So, part 1, as you can see, we're still in MS Paint. Okay, so what is the AI, or basically what an AI agent should think of, or what we should think about? The first thing we need to know is that we have MS Paint to write, obviously. Okay, so the first thing we're going to need for our AI is what is our AI and what is, of course, the player. So I'm going to write AI and P will stand for player. Okay, so basically we need a separation between ourselves and other AI agents and of course the player. So this is going to be our first problem. Okay, so we're going to find out all our problems at this point. And here's our problems. Okay. Secondly, since we know who is and who is ours and who is the player, we have a distinct separation between the two. So the second thing to know is, well, it will be what do we do if we know who is the player? Do we search for him? Okay. Do we attack? Or, well, what exactly we should be doing? Both of these will lead into different stuff. Okay, so let's say if we were attacking, are we seeing the enemy? I'm going to just make an eye over here. Okay, or there is no enemy, and I'm going to make an eye with this. Okay, so each of these, of course, will lead into another thing. So if we are seeing the enemy, that will mean what are we doing? Are we going undercover? Okay, or actually that's supposed to be a rifle. Or are we actually shooting him? And if we do not see the enemy, what should we do? Should we search? Should we ignore? Or should we, do something else? Should we still go take cover? Just in case we can see or the enemy, or we wait till the enemy comes in. Okay, of course this is an oversimplification of things. And again, for search, what should we be doing? Should we be looking out for them? Should we be, standing guard? Should we patrol? And stuff like that. Okay, so for each of these to exist, it does need to be a middle point between these two. Okay, I don't know why I did a plus. So let's say a 1 point B case. Let's bring it over here. Okay, and what will be that case B? Is, of course, do we see somebody or do we not see him? Okay, so if we see somebody, we have the identification. So we see something. We do not know yet what it is. Is it a friendly? Is it a player? Is it ourselves? So we need to identify first. The first and most foremost thing we need to do is, of course, identify, and this will be the first check we're going to do. And we're going to see in this case a few examples of how we can use identification, what should be used, where, when, and stuff like that. Afterwards, we're going to decide which, we're going to see how to optimize the identification. Okay, and how we can actually manage not having only one enemy. Of course, if you only have one enemy, then you are pretty much free to do a lot of stuff. But how we can manage a lot of enemies, and how we can even manage, groups of enemies, so there is a little bit of coherency and stuff like that. So our first problem we're going to solve today is the identification. Okay, and we're going to focus not only, or as I said, with a single enemy, but we're also going to have in mind the optimization. So let's go back into Unity, and we're here back again. As a reminder, focus on understanding the what the concepts I'm going to do today are, instead of trying to copy the scripts you see. So we're going to create just a test script. Let's call this, let's call it enemy AI for now, and we'll see what we're going to do with this in a bit. Now let's create something that it shows us that we are who is who, basically. Let's make a capsule. Let's create an empty game object, and we basically want to make a nose so that we know where we're looking for. We're going to add we're going to add animations, models, all that. We're going to do them when we're going to cover it, and we're also going to cover it to show you how you can exactly do them. Let's put something like this. Okay, we do not worry about the player at this point. So let's parent the capsule. Let's call this AI. Drop the enemy AI script. We do not even need caps collider in our case. Well, the best approach will be, the good approach will be to just create an empty game object, remove this, parent this, or this, which should be the visual, which later is going to become an actual model. It's parented 000. Okay, do not forget to do that. Let's parent over here our enemy AI script. Okay, let's tag it also. Let's create a capsule. Not a capsule. We have a capsule. Let's create a sphere at this point, so that this will be our actual player. Okay, not that there is a reason to delete the collider, since we're not going to do stuff that require a lot of performance. Okay, so we have our enemy AI. The first thing to know is to have a target. Okay, so on update, what should we be doing is, of course, looking towards the target, the first thing. Okay, so if target, let's just do with the basic stuff. Okay, let's do a vector 3, direction, target, position minus transfer dot position. Hopefully this isn't the first time you see this. Oops. Let's kill the Y. Okay, and we can do a simple, let's call it target rotation. And let's just do the simple stuff. Okay, there's nothing elegant about this. Okay, we're just doing it so that we know that our enemy is actually seeing the target So we have a distinct separation between not having a target and having a target. Okay, and then we can populate the stuff we have on our target. Let's we have our script. Let's hit play. Okay, and into our scene view we can see the player, and of course the AI doesn't know what the player is, and assigning this first, it's going to look towards our player, and wherever our player is going to is looking at it. So we have a distinct separation between not knowing where the AI is, or where an enemy, in this case it's the player, is, and where the AI is looking at. Okay, so yeah, I deleted my masterpiece in MS Paint, otherwise we will go back. So okay, this is the first way. So we need to give this guy somehow it can identify by itself the actual AI, the actual target or the player. Usually what we did on the previous on the advanced AI, not just the previous, is drop a sphere collider on an empty game object that goes underneath your AI. Let's zero this in. Okay, make the radius. Let's make something smaller. Okay, there's no need to do something that big. Let's put this out here. Okay, rigid body, and we of course need a collider. Let's just add the box collider, doesn't matter. Let's also make it kinematic, that is not falling. Okay, so this, let's call this view. Let's call this is trigger. As I said, do not try follow along. We're going to delete all of this. Okay, no, we do not want to save. We want to, well, actually, let's just save. Let's create a new folder. Since, and then let's put this tests in. Not that this matters. So in our script, what we will be doing, if our sphere collider was on the same level, well, let's just add the sphere collider directly on our first level, so we do not have to worry about creating more scripts. Okay, radius 5 is trigger. So back to our script, we will call on trigger render. Okay, collider other. Now, since there's only two colliders in our whole scene, in this case the player collider and the trigger collider, and we know our own collider is not going to trigger our own our own side collider is not going to trigger its own self, so we do not have to boot an if other, look for a component that's going to be unique on our player, and run the behavior you have over here. So in this case we can simply do target equals other, or other to transform, more correct. And just for fun, let's put void on trigger exit. Okay, if a collider exits, then that means it's probably a target. We do not have a target anymore. Let's close this and let's hit play. This is going to be annoying pretty fast, so let's drop it over here. So this is our player, and this is the side of our AI. So if I go close to him, okay, he looks, okay, they're not on the same height, but he looks on our AI. It's inside a collider, and wherever I move that it is inside our collider, then that means the enemy is looking at me. However, if I go outside of his view, okay, then that means he has lost sight of me. Here's another problem though, and of course this, you can use this depending on the time of game you are making. In some games, even if you approach them from behind, they will see you. if you approach them from the front, you know, they will always see you, of course. But in some other games, in something that's more, let's say, realistic, okay, if you're moving into from a distance, basically, not from distance, from an angle that they are not looking at, then they will simply ignore you. Okay, so what we can do is, if we have a target, let's find the, we still need the direction, and we're going to keep it as Y, as it is, but before we rotate, we're going to look for the angle. Vector 3, the simplest way to do this is between where a character is looking for at and what is the direction of the enemy. And depending on the angle we're going to set here, if the angle is lower than, let's go with 45, then that means we can actually rotate. If the angle is higher than 35, then we are good to go. There is no point in, you know, having our target, you know, it's behind us, we're not looking at it. Okay, this is the simple way to do it. You can also do you can also check for the dot product, which is going to give you a negative or positive value between if your character is behind you. So essentially what it does is doing an angle, it basically does this. If the angle is lower than 90, then that means the object is in front of you. Okay, let's test this. If I go and approach from behind, okay, nothing happens. If I go in front of him, then he's actually looking at me and he's following me around. Well, he's actually rotating. If I keep rotating, let's put him on the same level. If I keep rotating slowly, okay, he will follow me and he will actually look at me all the time. Okay, so this works. Now, there is a slight problem at this point, and here's where these things get complicated. Okay, we actually have, we are using the physics engine to do something we can simply do to do the same job we can do with 3 lines of code. Okay, so let's go back into our script and let's get rid of all these. So, what if we already had a target on start? Well, actually, we're not going to add a start, but what if we already had a target? And I mean, by, from starting the game, we already knew who was the target. So we're going to have a new bool, which is going to say us that the character is in range or not, and we're going to add, let's say, is in view. Okay, so we're going to keep the if target just so that we do not get errors if we do not assign it from the inspector, but we're going to focus all this and we're going to throw this in is in view. Okay, and it will only run if our character is in view or not. So, how we say a character is in view or not, without using any colliders, which means without using any of our, without using any of the physics resources. Okay, the optimized way. Well, it's really simple. What is a cycle? A cycle has a radius, and that radius means from the center of the radius is from the center of the of the sphere towards the edge. That is the radius. Okay, what that will mean, actually I think hold on, because as you know, English is not my main language. Yeah, I said it correct. Okay, the radius from the center to the circumference. Okay, so that means it's a distance between the center and the 5. We know which is the center. What we need to know is if the player is under the distance of a radius without using any of the sphere collider. So I'm going to remove the sphere collider, and I'm also going to remove my box collider and rigid body. Now, of course, in an actual game, you're going to have both rigid body and a collider on your players. Okay, but you won't need to have them on your AI. Obviously, you actually need to have them because you probably want to shoot at your AI. Okay, but we're just talking now. Okay, just keep that in mind. I'm just going to show you the little things you need for this. So, how to say if it's in view or not? Well, very simple. Distance vector3 dot distance. Okay, and from our own target position. Oops. Well, from our position to the target position, and this should be a float and not a float. Whatever. Okay, so simple enough. If distance is lower than, let's say 30, and I write 4. Anyway, let's say 4 is in view. True, or well, you know. Okay, is in view. If the distance is lower than 4, then that means he's in view. Otherwise, it's going to be false. Let's test it. Okay. However, do not forget to assign the target. Hit play. And we have a target because we assign it, so we always know what the player is and where the player is. But we're only checking if he is inside a radius of 4. Okay, if I move close to him from behind, then he doesn't know that I'm there. And if I move forward, then he actually starts looking at me. Okay, I think it's, yeah, maybe 4 it's too small. Or it's too fast for him. Anyway, the distance doesn't matter, you can change it. Okay, without relying either on layers, without relying on anything, on colliders, on physics, or anything. Now, how many times the physics operations run? Okay, it's determined by, let's see if they change this, because I forget. Okay, the fixed time step. So whenever you use something with physics, then that means it's going to run, I think it's about 4 or more times, depending on what they have on these functions. So when you write on trigger ender, okay, and so on. Okay, so that means in a frame we rely on the physics engine to run something we can only run in one frame, since the position between each frame won't really be that, won't change that much. So the way we were doing it with the colliders, we were relying on the physics engine to try and do something. We were doing it, let's say 4 times, roughly 4 times. It could be actually more, now that I think of it. Okay, to do something that we can do only once in a frame. Now, in theory, let's raise the distance from 4 to something like 10. Okay, in theory, depending on how fast your character will move, and there's no need to actually check if your character is in a view of an enemy every actual frame. So why that is? Because if you're moving with a certain distance, you will always know the maximum distance that your player can have. Okay, so if you're moving 0.0001 something like that, okay, for each frame, so you are moving on 6 frames, or 60 frames, you actually have moved 2 or 3 points. Okay, the distance between all of them wouldn't really matter, especially for something like field of view. Wouldn't really matter. It won't make any difference. So you have 60 frames that you are searching for an enemy, which you can really clamp down to around 10 of those frames that you can actually use. Okay, so the simple way to do this, and keeping in mind of performance, actually, yeah, right now our the logic we have is really small, that it wouldn't really make that much of a difference if we run the profiler. But let's try to see if there is any change. As I said, it's very small to even worry about it, especially at this scale. But let's just see if there might be a chance that we might see something. So let's hit play and let's try to see some stats. Of course, it says 100 FPS, but if you wanna spice up things up, if you really want to do that, you can go to quality and you can set don't sync. And actually I need to set it again, I believe. Yeah, don't sync. Okay, what's the FPS now? And that actually didn't work. Yeah, it worked. Okay, now it's at 1000 FPS. So let's see if we actually can see anything, which I don't believe we're going to be able to see. And yeah, over here we have one update, I think. Yeah, we have the behavior update, enemy eye update. We are going at 0.01 milliseconds. One call on a self. Yeah, as I said, this is really nothing, but it's constant. Okay, it happens all the time, and this is probably from the wait for present. Okay, which goes away. Actually, because I have more software that have to do with the GPU, I might be getting this call. You might get this also, but anyway, it doesn't matter. Yeah, this is unimportant, but you can see that this is really constant. Okay, behavior update will either be 1.4. Now, do not think that 1.4 is something, or 1.1, because it's at 0.00 milliseconds. Even with the updates we're going to, or the optimization we're going to do, as you can see, if it goes over the 2 decimals, it just ignores it. So we might actually not see any much more difference. So let's do this. Let's call this, let's encapsulate all of this. Okay, let's call this field of view. And what we're actually going to do, yeah, I'm actually going to just duplicate the AI. Yeah, let's try this now before we try this, and we're actually going to put the player inside the view of our AI. Okay, so we're going to duplicate these guys 4 times. And let's see if we ever going to see an update over this. So each line is 4. Okay, 8, 16, and so on. Let's see if we see a change over here. Let's put the player. Now notice that not all of them actually is watching the player. So let's change the view to something. Let's go with 200 because we want all of them to see us. Let's see what that is going to do on our behavior update. Although it's fun, they do a little wave. Okay, let's see if it actually changes. And some of them do not update because the angle, of course. Let's see. We have our update. Okay, you can see that there is also, because we have the main view over here, down here, we have our behavior update, 39 calls. Okay, and we're now up to 0.15 milliseconds. Of course, this is really nothing. Okay, and you can see that it goes 16 by 5. But this is mostly moves at this range. You can see the milliseconds. I think I saw a 21 over there. Let's see the spikes. The spikes are obviously from the graphic waveform present. Okay, and yeah, I think we're good. Okay, we can see that, yeah, we're always above 20. As I said, these are still milliseconds, so yeah, nobody cares. Let's take all this now. Cut. Let's add this over here. If we drop this over here, then it's going to be the exact same thing, of course. Now, instead of having the field of view, instead of doing this on every frame, the simple way to do is to add this. Let's make, well, actually, let's make just let's call this cycle. Let's drop it at 10. Let's call this counter, which will be at 0. We'll start 0. Okay. So, instead of doing this every frame, we're going to only be adding on the counter. Okay, so every frame we're going to be adding this. Now, if the counter is higher than our cycle, so that means on the 11th frame, okay, then we're going to reset it, and then we're going to try our field of view function. Let's see what this changes into our profiler, if we can even see it, of course. Okay, let's move this guy around. And you can see that we get even more FPSs because we actually have broken it up, and you can read it and you can see the spikes. Even though it's a little too small, you can see the spikes. So this is every 10th frame that it actually looks for our character. Okay, let's see it. This is also the camera render. Of course, because this actually rotates the players, so every 10th frame we actually rotate to. So that might be a little issue. We're going to resolve this in a bit. Okay. So, let's see what this does. Of course, every 10th frame you can see that we are back again on the same numbers. But on the frame exactly after, we went from 0.15 milliseconds to 0.1 millisecond. Okay, I hope you can get why we do this and how we do this. Let's take this, and instead of doing this every frame, and yeah, let's take actually the angle. Let's take the rotation out of it. Well, actually is in view, and let me think. Yeah, I'm going to delete this and this, and I'm going to take all of this outside of the function. and we're going to add this in here, is in view. Now you will think that, yeah, but what you're essentially doing is that you're running the, yeah, you actually took the code that, you know, makes the overhead, quote unquote, all the overhead, and you put it inside the update, and you'll be right, but you'll see why we do this. Okay, so if we took this out of the equation, we're going to see that we're pretty much back at probably the same numbers. Okay, we have our behavior update 0.8 and entirely the same, one frame above we have the 13, which is why, because we start rotating, and we start rotating. Okay, now we have it, yeah, it's pretty much slightly, I can see that there is slightly more, you know, down to the 15, to the 14, although there is a lot of 20s. Okay, again, it's not really a problem. We're doing it, yeah, you can see that we're running 1000 FPS. So, and the reason why we have our field of view different, and we're going to do this every 10 frames, or well, you can actually go even more. You can actually go with 30 or 15. It's entirely up to you. So you're breaking it up even more, is because, okay, we only have one player. What will happen if we had a lot more than one player? What will happen if we had a list of players? Okay, and that list had 50 or 100 or 200 players. Okay, you do not want to run and search inside a list and do an entire for loop through, you know, through all your players. You want to have, you know, you need to assign a little bit the overhead. Let's see if we can, you know, level a bit the overhead. So what we're going to do now is on start, apply on our enemies. On the counter, we're going to apply random dot range between 0 and 15. So for each enemy we have, we're currently, basically, we're breaking up their update cycles. So when they are actually updating, and yeah, so not all of them are going to update and search for the same, for the player who's not going to run this on the same frame. And if we actually took these two, we're going to see a bigger change in this. But let's see if this thing, again, as I said, the major overhead is this. Okay, it's not really searching for one distance and turning one boolean true. The major problem is rotating to see the target. And after that, we're going to try this with our trigger render, and yeah, you're going to see how the difference there. Let's stop this. Let's hit play, and you will probably see that. Let's leave it at this. You can see that instead of having all the overhead on one frame, of course there's going to be some overlapping because that's how it is. We simply break it up a little bit more, and where we were towards the 16 to 20, okay, we're now closer to 10. Again, we're still on milliseconds, so nobody cares. Now let's try something else, and we're going to try, or actually let's try the colliders again, just to prove my point. We won't need to touch this. Let's try void on trigger render, And yeah, I should have deleted this. I should have deleted this, this target, and we should just do a target equals null on start. Yes, let's remove this also. And yeah, on trigger render, collider other. Here's the problem. If we add sphere colliders to all of this, you're going to have around 40, at this point, you're going to have around 40 to 50, or how many you have over here, overlapping colliders. So we need something to especially say that we have, you know, that there is a player inside your collider. So we're going to use a tag that means one more if check. Okay, and we need to check now if other dot GameObject dot tag equals, is it player or player controller? Player. Okay, here's another problem that you might not know. If you do this, you're forcing Unity, if you write a string like this, you are forcing Unity to check or to recreate the string on every frame. So that means even more performance. To fix it, for now, let's call this string player, and let's initialize it as player, and let's drop this over here. I think actually it has a GameObject compare tag. Yeah, it does, and it takes a string. Compare tag player with what? Is GameObject tag with, oh, so yeah, this will return true or false if I write it correctly. Let's see. Okay, so if we have a new if statement over here, so that means one more, and if we have the string collider, yeah, if we have a player collider, then we're going to assign him as the target. Okay, we need of course the opposite of this, so even more resources. Exit, and if it's the player, then we're going to assign him as null. So everything else is correct. If we have a target on every frame, and even if we do this, you know, every 10 frames, we'll see what it's going to actually require for the what's going to require for performance. Let's delete all of this, because we need to initialize one of them. Let's delete all this too. Okay, so let's add a collider, and we need a sphere collider. Let's make the radius something like 30, although it might be a little bit too big. Anyway, we still don't care. We're going to set this as trigger. We also need to add a collider or something to our player. Let's go with sphere, and we also need to have a rigid body. I'm adding the rigid body because we might actually see spikes, because if you move a collider that doesn't have a rigid body on it, okay, on runtime, and it isn't static, then you are forcing Unity to actually recreate a collider every frame. Obviously we do not want that, and now that I think of it, let's add a rigid body, just you know, just to make sure this doesn't create garbage where we do not want it, even though, and yeah, it will actually create garbage because we are rotating the collider, or well, probably it's going to create garbage, I don't know. So let's make 5 of these guys. Okay, and let's bring it back. We have 10. Let's go with 30, although I think we had a little bit more than 30, or let's make a few more. Okay, let's just leave it at that. And let's hit play. You can see not only that I get, look at these spikes. Okay, you can see that you have your physics process reports to be at the, you required 2.37 milliseconds to run all your physics. Okay, just because we had spherical lidars and because we're doing everything we're doing. From the script's point of view, we're doing nothing. We're only rotating, we're finding a direction, and we are only rotating. Okay, very, very understandable and very, very simple. So, yeah, I don't think I have anything else to add on this. It speaks volumes. From 1000 FPS, we had a spike that dropped us down at 120 FPS. So that is about 880 FPS gone wild. Let's see. You can see that we get, instead of having the overhead from the behavior update, we get it from the physics processing now. Okay, but you can still see that the FPS are really horrible. Or well, the fix, because we actually do not have to, we're not calling this on every frame. Okay, this only runs when you enter or exit the collider. But if your character leaves, you can still see there is some really nice spikes. Okay, from where we didn't use anything from the physics, okay, it wasn't even visible in our profiler, we fall down into requiring so much more. And I think, yeah, so here's more spikes. You can see that this is probably the old trigger ender, or it's one of them. Anyway, we made it clear which is more and more, performance. So let's delete all this, and what we can do now is, instead of keeping every guy or every enemy AI updating itself, okay, we can actually calculate an overhead we can have. Let's add like that. Let's delete this. Let's delete the target and let's delete the counter. Let's leave no, we do not need this. We do not need the string. We have our field of view. We have everything. Okay, so we're back to where we were, apart from the fact that we do not have any targets assigned, or I hope we do not have any targets assigned. Let's see if we actually have them. So let's select all of them, remove the player, and let's remove this too. So next thing we're going to do, let's call this AI director. Now keep in mind that in your actual game you're not going to have a rotation and the field of view. Okay, you're going to have so many other behaviors in it. So we need to know who needs to be updated, why he needs to be updated, and if you want to skip the next frames you're going to be updated. You probably have seen it in other games. For example, I think it was in Dark Souls that enemies that were too much far ahead, you might be able to see them, but they were way too far ahead. Okay, they were moving way slower than if they will be moving if they are close to you. Okay, that is pretty clear way to say that, you know, you're not updating on every frame when you are far away. So, and we can actually do this now or leave it for part 2. And okay, I think we've covered a lot enough for this one, so we're going to leave this as a teaser. We're already over 50 minutes, and okay, on the next one we're going to see how we can actually use a single script to control every character or every enemy AI, to see how we can run our behaviors, and we can set up criteria to separate them from lists, to, you know, add them where they need to be. Now, as I said, with the things we cover over here, it's mostly theory. There's no need to even write them. Okay, and we're going to delete and add, and I'm basically covering examples rather than telling you what to do. Every game is going to have different, you know, it's going to need different AI, it's going to need different structure, it's going to be entirely different. On a later part, we're going to decide on what we're going to use, although you can probably guess which examples we're going to use, and we're going to tailor them to focus on the 2 cases we've already seen, which of course is either the advanced AI we had previously, or the bot AI we're going to see for our, you know, for our third-person shooter beta. So, you know what to do. Like, subscribe. If you like to see more and you want to see it earlier, along with all the other nice videos I have with all the other series, okay, then you can support me on Patreon, and you will also be able to see them much earlier. You also get access into a Google folder with all the scripts. You also get discount codes if you want to buy a package. Okay, depending on your tier, you're going to have different rewards. And of course, the other way you can support me is through Gumroad. If you want a project, okay, and you want to help me out, and you do not want to sit and write the scripts, okay, then by grabbing a project or 2, you know, or 3 or 4, I'm not going to put a limit. If you want, go buy them all, and in turn I can keep continuing making all these nice videos and make this type of different things. So let me know what you think about this one. Okay, it's a new, or well, an old style, but I think this one will work for the AI, especially because you have to know what exactly you are doing and why you are doing it to be able to modify it later. Okay, I think this is an exception that we can do for this one and actually write it along. It might going to take a little bit more time to finish, because we have to cover, as you can see, we've only covered field of view in 50 minutes, where we can have done so we were doing this the old way. We will have covered the field of view in, well, 2 minutes, okay, instead of 50. So I'll see you on the next part.